Hey guys, earlier today we looked at the introduction to this section on 1.2, finding limits graphically and numerically. And we looked at the big idea of what limits were, and we looked at what they were generically. So remember, just to remind you guys, it says the limit is one number, L, that you can keep f of x very close to by keeping x close to c. It doesn't necessarily have to be equal to c in order for there to be a limit. So today, what we're going to be doing is we're going to be looking at evaluating limits. In section 1.2, we're going to be looking at evaluating them numerically and graphically, meaning using table of values and also using graphs. In unit 1.3, we will be looking at them analytically, so using algebra and calculus. We'll be looking at it a little bit during this video as well. But let's look at the first example. So here's our first example. So it says here, we're trying to find the limit as x approaches 0 of this function. So x over the square root of x plus 1 minus 1. So the first thing that you should try to do is to try to see, okay, what happens when x is equal to 1? What's the behavior? So let's look at it algebraically first. So what happens when x is equal to 0? So when we plug in 0 into this function, very bad things happen. Very, very bad things happen. So when we plug in 0, so x is 0 right here. And if we simplify it, we end up getting 0 over 0. Zeros in the denominator are very, very, very bad. This is what we call indeterminate. It's called indeterminate, meaning we need to do more math. We need to do more math. So let's see what happens when x is close to 0. So not when it's exactly equal to 0, but what happens when it's close to 0. So we're going to look at this graphically. We're going to estimate graphically. We're also going to estimate numerically using a table of values. So we're going to graph this. So when we graph this, the graph of this one looks like this. Let me pause this for. All right, I want to show you guys how to use this graphing calculator. So here, let me start all over from the very beginning. So the TI-84 plus, you go to the y equals button, and here under y1 we're going to put in this function. So with this model, you can press this green button, F1. This menu will pop up. And we want the numerator over denominator. That'll give us a fraction bar. So this fraction bar, we're going to put x in the numerator. And the denominator, we're going to put second square root. So we have the square root button right here. And underneath the square root, it's x plus 1. We're going to move this arrow over so it'll take us outside the square root. And this is minus 1. So let's graph this. And if you graph it, it looks something like this. However, when we use the trace function, so there's a trace button right there, the trace button right there, if we trace it and if we go over x equals 0, you see how the y value, there's no y value there for x equals 0. So this is that indeterminate value that we saw algebraically. So this is what it looks like, but if we look at it graphically, it looks like it's at about 2. So the y value looks like it's about 2. So it seems like a good estimate, but let's look at it numerically. So numerically, when we look at this function, we're looking for numbers close to 0. So we want to see the numbers as x approaches 0 from the negative or from the left. So ones that are slightly smaller than 0. So numbers that are slightly smaller than 0. And we're also going to be looking at numbers that are slightly larger than 0. So numbers that are slightly smaller than 0, we have negative 0.01, and I also have negative 0.0001. So let's plug this in. I'm going to use my calculator again to do some of these calculations. You can also use the table function. I'm just going to use the calculator. So for this one, what you guys are going to do, we're going to use that function again, but every time we see x, we're going to plug in, we'll start with negative 0.01. So I'm going to put negative 0.01, and then you can either do the fraction bar, like we did earlier, and so we're going to have the square root of negative 0.01 plus 1, and then outside the square root we're going to have minus 1. Enter, and there's our value, about 1.9949. Alright, so let's look at this one. So what we can do, instead of typing everything out again, you can scroll back up, press enter once it's highlighted, and it'll give you the that function again, and you can, this time you can edit it. So I'm going to change this negative 0.01 to negative 0.0001. And you can do this by inserting. I'm going to insert 2 zeros. So second, insert, and I'm going to type 2 zeros. It types it to the left of the number. And then I'm going to press enter again. This is 1.9999. So it seems like from this side, f of x is approaching 2, which is what we predicted graphically. So let's look at it from the right-hand side, numbers that are slightly larger. So let's look at, we can go back up here again. I'm just going to change all of these negative signs to positive signs. So I'm going to delete them. There's a delete button right here. I'm going to delete that negative sign here. And I'm also going to delete the negative sign right here. So it's 2.00004. 2.0000. And then let's look at it when it's 1. So again, I'm going to go up here. I'm going to, this time, I'm going to delete 2 of the zeros. And let's see what this is. Enter. So this is 2.00498. So f of x also approaches 2 as we get closer and closer from the left. So we can conclude, both graphically and numerically, they both agree that this limit is approximately 2. All right, we are going to, let me see, I think we have time for one more example, so let's look at one more example. Oh, this one's not it. Oh no. Okay, here we go. Example number 2. So example number 2, we're going to look at one that's piecewise. So we're going to let this function look like this. It's going to be piecewise. We're going to look at the limit as x approaches 2 of f of x, this piecewise function. So the piecewise function is 1 everywhere except at 2. At 2, it's equal to 0. So it's piecewise at 2. See how there's these weird parameters that it has? So what happens at x equals 2? Well, it's piecewise at x equals 2. So I'm not really sure what that means. So we're going to look at the limit. We're going to look at what happens when x is very close to 2. So again, graphically, we're going to estimate graphically and numerically. So graphically, just like I stated before, we have this right here is, it's going to be 1 everywhere. So it's going to be a horizontal line, 1 everywhere, except at 2. At 2, it's equal to 0. So at 2, it's equal to 0. So this is piecewise. I didn't say earlier in the other one, but this is what we call discontinuous. So there's discontinuity here. There's discontinuity here. So right here, there's discontinuity. Remember, that's when you have to lift up your pencil or pen to draw the other point. That's what we call discontinuous. So there's discontinuity here. There was also discontinuity in the first example. I'm sorry, I didn't say that. So this is discontinuous. So discontinuity. So there's discontinuity there. And there's also discontinuity here. However, when we look from the right And when we look from the left, so as we go along this graph from the right and as we go along the graph from the left, this y value is still going to be 1. So it looks like this is going to be 1. If we look at the y value, it looks like it should be 1. Let's look at it numerically. So for every single number other than 2, it's always 1. It's 1 here, it's 1 here, it's 1 here, it's 1 here. So f of x, it approaches 1 from the left, and f of x also approaches 1 from the right. So we can say that the limit as x approaches 2 of f of x, which is this function, is equal to 1. All right, thanks.